And there we go. We are live. I am live here today with Mikael Östling, Professor Mikael Östling, who also happens to be Deputy President of KTH, the Royal Institute of Technology. And I'm super happy you could join me in the studio today, Michael. Michael.
Yeah.
I don't know which one you prefer.
In English, Michael.
In my English, Michael. So I'll call you Michael. And you're not only here because you are a Deputy President. You are here because you are a professor in, what is your actual subject that you're professor in?
The actual subject is solid-state electronics.
Solid-state electronics.
Most people don't understand what it is, so I usually say nanoelectronics or microelectronics if it sounds better for
and in layman terms, how would people out there encounter solid-state electronics in their everyday lives?
That's the semiconductors. They show up everywhere.
Semiconductors
and my subject, solid-state electronics, are well together.
Okay, and I actually think that most of us have heard of or read about semiconductors in the papers and on the news, in the kind of, there's a crisis in the semiconductor industry, but I don't think actually that many people actually know what a semiconductor is or what it does. Could you give us a very short presentation about that?
Absolutely. Semiconductors are everywhere, and to say they are not conductors, they are not insulators, they are semiconductors. Okay. That means it's simple. I go directly into physics. So we have electrons in one band, the valence band. And to make conduction, we need to lift these electrons to the conduction band. That requires some energy, voltage. So you put some voltage on, electrons go up to the conduction band and they conduct current. So, and you can control that. So that's the basic function of a semiconductor. Normally we do that in silicon, the silicon material, which is fortunately very frequent to find on the planet Earth.
It's one of them. Is it one of the more?
One of the more. I think 30% of the crust of the Earth is by silicon. It's you go to the beach. And that's where you have silicon in the form of silicon dioxide. That's sand.
It's sand.
So we have lots of it.
Yeah.
There is no shortage of semiconductor material.
Okay. But let's talk about the crisis right away. We can come back to what they actually are and what they do. But is there a crisis in the semiconductor industry then?
Well, it is a crisis in the way that due to several facts that came together, the COVID, some unfortunate natural catastrophes made some shortage in the production line. With the COVID pandemic, many people or many companies thought that the demand would decrease, especially the vehicle industry. Instead, we sat at home and wanted to have some entertainment.
Of course.
And we started to buy computers, audio, what do you call it?
We bought even more home electronics because everybody was at home.
Absolutely.
Yeah. Okay.
Yeah. The vehicle manufacturers canceled their orders, and then they came way back in the queue to get the chips. So that's like a traffic jam, and that's still going on. But of course, production quantity has been increasing, but not quick enough. So we will still have this sort of delay for quite some time.
So, but when I'm asking the stupid questions here, but so when the automotive industry is complaining about that there's this shortage, it's kind of self-inflicted?
Partly.
Yeah. But I know we had some factories that couldn't, due to, as you said, natural catastrophes and things that, exactly. I know that as well.
Yeah.
But then again, okay, so I'm sorry for sticking to the crisis part here, but today we have a different geopolitical landscape than we had like 4 or 5 years ago.
Exactly.
Is that affecting this as well, do you think?
Absolutely. Well, not directly, but it will be affecting it very, very severely if the diplomacy in the world gets out of hand. We know that most sort of advanced chips are produced in Taiwan by a company called TSMC.
One company.
one company which is completely dominating the market. And sitting in Taiwan, we have two things. We have the geopolitical thing, but we also have, I would say, something that we didn't pay attention to. It's an earthquake zone. So if something happens there, with or without the politicians, I'm not sure if they can start a earthquake, but almost.
But the super chips that we're talking about, what are they used for?
They are used for the most advanced iPhones, the most advanced computers, self-driving circuitry for the vehicles, all these latest generations of chips that are really having like 50 billion transistors in one chip. These are the super hefty chips that we get from them. We get them from Samsung in Korea as well, and one or two others. But basically, the capacity that TSMC is cranking out is so large, so we're very dependent on the TSMC company.
But are there other chips than the super chips? I'm guessing that there are.
There are a whole variety of various chips, also of different sort of nodes. We call each generation a node. And now we have a node called N3.
N3, okay.
That means that the transistors' smallest dimensions are around 3 nanometers.
That's very small.
That's smaller than you can imagine. It's not even a 10,000th part of a human hair.
Wow.
Yeah, so you cannot see them.
No, okay.
You have to pay a lot of money to just be able to see the transistor. So it's a fantastic thing. 50 billions in a chip.
That's I can't even fathom the
right. So what is happening now is that we realize that it's not good if all the production quantity is produced in one or two places.
Of course not.
So now US has a CHIPS Act. European Commission has also stated a European CHIPS Act. And there's so much money going into building capacity in Europe and in the US to bring production quantities to us so that we are not dependent on natural disaster or political disaster.
Of course.
So this is what happens. But it takes time before everything is sort of
course,
covering our needs.
And then, many of the viewers are here. They are entrepreneurs to be or seasoned entrepreneurs. We have some investors. We have people from governmental bodies as well. And thinking, and the way you're speaking now, I'm thinking to myself, oh, as an entrepreneur, this is a business opportunity. I can start a chip factory.
Yeah.
Maybe I can. Or can I? How difficult is that? How big is this undertaking to like, if we wanted to if a European here would wanted to get on board and help Europe, increase their chip building capacity.
Right. That takes a lot of money. So unless you're Elon Musk or something of that kind, you cannot do it. But
this is Håvald. I'm looking at you in Norway. I know you're up there.
Okay. So a new mega chip factory can take you back like 100 billion kroner.
Yeah.
So it takes some efforts to set it up.
Yeah.
In the US, according to what I know now, they are planning to bring up about 13 mega fabs. 13 mega fabs in some places, Midwest and a few other places. What is interesting, since we are in a university here, is the supply of trained engineers to run the show.
Of course.
Yeah. So this is not verified, but around 10,000 engineers per year is the demand for educated people now to set up all this
in this business only.
Yeah, exactly.
So
and it's various kinds of engineers, of course, not just the electronic designers and so on, but process engineers, mechanical engineers. God what knows what kind of engineers they need, but for the whole production, it's fully automized. So there's a lot of robotics and super precision instruments.
It doesn't sound like the factory of yesterday.
No. Actually, we cannot afford to have too many people inside because people inside make mistakes. Robots don't do mistakes. and it's so costly. So if you have a batch of silicon wafers that are being produced, and if you drop something there, I mean, you're out of business completely. So we cannot afford to have human workers doing too much.
Well, that's anybody with kids in high school. You know, that there's a job to be found. Send your kids to university, preferably one in Stockholm, Sweden. That trains very good technical engineers. Well, that sounds like the Rust Belt is going to become a silicon chip belt.
Could be, unless they do reskilling, so that the Rust Belt workers are sort of better trained, because this is highly trained people that they need.
That's very. I mean, that's you said 13 big factories. Yeah. Well, what about Europe and Sweden? Are we going the same direction?
Not in Sweden. We can still produce very well trained engineers, but in the Germany and France and Italy, there are efforts to also bring in more chip factories.
Yeah,
they already have some chip factories in both the Grenoble area in France, in the Dresden area in Germany. It's called Silicon Saxony, by the way.
Oh,
and in Italy, they have also manufacturing in Sicily. So there are quite a bit of activities in Europe, but we need so much more.
Yeah, I mean, you told me the craziest story about the Tesla Model 3.
Yeah. If we leave these mega chips with the 50 billion transistors and think about power electronics, the power transistors that can be useful to drive motors, to convert voltage from high to low, low to high, AC to DC, DC to AC.
As in when we're charging the car opposed to when we're driving the car.
Exactly. Both ways.
Okay, yeah.
And these power transistors in new materials like silicon carbide or gallium nitride are so efficient. So we need them greatly. And the production quantity today, or capacity today, is far too small. So the story with the Tesla is that Tesla is a very modern and forward-thinking car manufacturing company, and they put these transistors in their AC/DC inverters. And the whole capacity from the Sicilian fab doing these silicon carbide transistors is used to just completed for the Tesla Model 3.
So that one car model is swallowing the full production of those chips.
And that's for the entrepreneurs out there. We can do this. We can do this in Sweden. That's my vision.
Yeah.
Because these fabs are not the 100 billion fabs.
No.
These are pretty much smaller, but still very, very advanced. But you could set it up, I would say, for 5 billions. That's cheap.
That's nothing. No, but compared to, but then we're talking about the inverters.
We are just talking about the transistors.
The transistors,
and then it's up to yourself how you would like to design these transistors.
Yeah.
So you have one transistor doing the job, not 50 billions.
Yeah.
So you put them on a circuit card, a circuit board, or anything like that. So of course you have to do some design, but these transistors can be used for many different things. Not just for the Tesla inverter.
Of course not.
So what I'm saying is, when we have the electrification of the society, I would say that the charge stations themselves, where you put the charger in, they need also these power transistors. When we get the high voltage in from the power generators out there, whether it's windmills or water power, we need also to have this conversion from high to low voltage and from AC to DC and so on. And there's so much demand from the society. So I think production quantity is really in demand here.
But this is so interesting, because we keep on speaking about sustainability, leaving fossil, going towards electricity. But we tend to not speak enough about the bottlenecks to get there. I know. Okay, so now right now we have what we could say like an energy crisis going on, because the prices are going up and that whole thing. And in Sweden, there's a lot of talk about that we need to redimension and the whole sort of power supply net of Sweden.
Absolutely.
But as we go into even more electrification and even less fossil, I'm guessing that we'll need even more of this kind of technology.
Yeah. And just to give you an example, the world in total consumes today 26,000 terawatt hours. That's plenty. In 20 years, we will double that.
In 20 years only?
Maybe faster. It depends also a little bit on politicians. How much
but that still it's still mind-boggling numbers.
Right. So I mean, it's so much energy for the electricity. And we put up these server farms everywhere and so on. So we are just not using it wisely. But for every generation we do, we have a much more efficient, energy efficient installation. But still, we just double it and double it and double it. So we will basically consume double the amount of electricity that we have today in 20 years, maybe 15 years. But let me just give you an example then. So if we could improve the energy efficiency by putting these new type of devices there and save just 1% of the electricity, that's a small number. That would then be equivalent to not starting about 100 average-sized coal power plants.
I have to repeat this so I really get that. If we could save 1%, you're saying, by adding new technology, that will stop us from starting 100 coal plants.
Yes. The problem is that, well, in Sweden, we don't do that. We don't start them. Maybe we have something going on in Karlshamn, which is unfortunate. But in China, I would say 60-70% of all the electricity is produced by burning fossil.
Coal,
so there we should see a superb saving. And we need to do that. And we need to, of course, generate more electricity, but we need to save more electricity. And it's pretty easy to save electricity than starting up new factories.
So now suddenly we're talking about sustainability as well, and actually the whole sort of world moving from fossil into whatever is going to come next. It's fascinating how this plays into everything.
Absolutely. And just let me give an example of train technology. If we take a light train, like Pendeltåget, the Japanese have shown that in the Ginza subway, by introducing these kind of devices, silicon carbide powered transistors, they could reduce the power, the energy consumption in normal subway trains by 40%. 40%. 40.
That's an enormous amount.
And the same has been shown here in Stockholm by Alstom and Bombardier. They also did the same experiments, about 40% saving.
But this is, this is crazy. I mean, this is so interesting to hear. Well, how we can actually, this is something we can actually do to help the world move to a more sustainable energy, both consumption and also production, and indirectly.
So this is one of the more important things that we have to do. Of course, we have to think about the way we live, but this is, of course, still giving us a good quality of life. So I would say this has to be done. The problem is, of course, new technology is more expensive than the old technology. Who is going to pay for that? So if you operate your subway and you order a new train, you have to pay top dollar for the new technology. But if you run it for 10 years, you save so much. But is that the same thing? Who is paying for the,
of course,
for the operation?
Especially since politicians are only there for like 1 to 4 years. So it's
and also the automotive industry has been quite conservative. So I was one of the co-founders of a company that produced these kind of silicon carbide transistors. And we got some venture capital from Volvo, VTT, and some others. And we argued that, okay, technology is quite challenging, but we will fix it, no doubt. The sort of mindset to start using this is more difficult to have the designers design with the new transistors. And the car industry or the automotive industry said, there's just one parameter that is interested, and that is, can you give us 10 cents per ampere? 10 cents per ampere. That was the magic number for them at that time. And of course, we couldn't do that at that time because they didn't care about the drift itself.
No,
it's just the upfront cost. So that means today we understand so much about the sustainable society. So the cost upfront is less important than the cost totally.
Of course.
Yeah. But there's a mindset.
Indeed. I read about all of the AI that is, I mean, we're pouring resources into AI.
Yeah.
And the energy consumption by all of these AIs that we are creating will, I think, was like in 10 years it's going to be like 20% of all the energy that we. It's an enormous amount, and that, and again we need more electricity.
Exactly.
So by saving electricity, we can also reach a sustainable society faster, because that will also mean that we might not have to produce as much, but we'll probably anyway. But anyway, so. Fascinating. This is, I mean, I'm just looking at the time here. I mean, this is the world's fastest half an hour, as we say. It's just a half an hour coffee break. I am thrilled to have had spent it with you, Michael. Thank you so much, Professor Östling, for coming here. You're an entrepreneur as well. You've had 2 startups?
One big startups, and I have been investing in some others.
He's a very humble person. So. But any last words for our audience regarding the semiconductor business? Anything we can do? What can we do to help?
What we need to do when we teach technology at KTH is to have the full vision of what the technology does. Some people are interested in the valence band and the conduction band and are just focusing on that. We need to understand what can that do for our sustainable future, and learn how to argue for that. So we need to see the big picture to do the small picture. That's a very interesting thing. And I think our engineers need to have the basic engineering skills. And then you can do whatever you like.
Yeah. But that's the magic of having the basic skills.
Exactly.
Thank you so much for today. Thank you everyone out there. And follow Michael on LinkedIn, and follow KTH as well on LinkedIn, of course.
Maybe you put in an email or something.
I will. I'll put in contact details here. Don't worry about that. Thank you again.
Okay,
and
thank you.
Goodbye, everyone.
Bye-bye.